Hello everyone. Are there any difference between authentication and authorization in Kubernetes? What are the common authentication methods in Kubernetes? This we will examine in this video. Let's do this. In software system, authentication and authorization play a significant role in providing security. These terms are very different security processes that work together to provide identity and access management. In short, authentication determines whether a given user of a system is indeed who they claim to be. The easiest way to visualize this is using a username and password to complete an authentication process. Authorization, on the other hand, determines what the user can and cannot do or access in the system. This also means in a secure system, authentication is the first step and authorization must always follow authentication. In simple practical way, we have three building blocks, which are 1. Subject, users or process that want to access a resources, and 2. Resources, Kubernetes API resources type, and 3. Verb, operation that can be executed on the resources. I don't intend to make this video long, so the next video will be dedicated to understanding authorization. I encourage you to subscribe and watch out for the release anytime soon. So let's move to examine authentication in Kubernetes. User management in Kubernetes is a mixture of different approaches. All users and the internal components interact with the cluster via the Kubernetes API server. Requests to the API are associated with an external normal user or service account defined in the Kubernetes cluster. Note that normal user accounts are global and do not have cluster namespace, while service accounts are managed by Kubernetes cluster and modeled as service account objects. You can create and manage service accounts just like any other resources in Kubernetes. For example, using kubectl and YAML manifest files. This types of account is intended for processes in cluster components or running in pods. The credentials for service accounts are stored as secret in the cluster that are mounted into pods so that the container process can use them to talk to the Kubernetes API server. They are namespaced. Check the official documentation for more on service accounts. Authentication is carried out by authentication modules that depend on the cluster configuration. We will examine three methods in this video, which include static token files, OpenID Connect token, and X509 client certificate. Other methods are service account token, authenticating proxy, or authentication webhook. Let's start with static token files, a built-in strategy. This method is the most basic one that Kubernetes offers for managing normal users. Easy to understand and configure. In this method, you define a .csv file where each line has the following format. Then you pass the file when starting the Kubernetes API server processes using the token alt file parameter. To authenticate against the API server, you need to use a standard HTTP bearer authentication scheme for your request. This means that your request will need to use an additional header that is in the following form. Based on this request information, the Kubernetes API server will match the token against the static token file and assign user attributes based on the matched record. Note that when using kubectl, you must modify your kubeconfig. You need to do this using kubectl command. This method is unsecured. Exposing a token file compromises all cluster users, but good for development environment and learning the principles behind the authentication in Kubernetes. but it is not recommended for production use case. Next, let's look into OpenID Connect tokens, which are considered an industry standard. Using OpenID Connect, you can achieve a single sign-on experience for your Kubernetes cluster. This is an authentication layer that is created on top of OAuth 2.0, which allows third-party applications to verify the identity of the end users and obtain basic user profile information. OIDC use JWT, which you can obtain using flows that conform to the OAuth 2.0 specification. The most significant issue with using OIDC for authenticating in Kubernetes is the limited availability of OpenID providers. But if you are deploying in a cloud environment, OTS1 cloud providers such as Microsoft Azure, Amazon Web Services, and Google Cloud Platform have their version of OpenID providers. So you do not need to worry much about configuring the Kubernetes API server and making it work with your chosen OpenID provider. You get it along the managed solution. And the last method we will look into in this video is X509 Client Certificate. Using X509 Client Certificate is another of industry standard for authentication processes. To keep this simple, this method works in Kubernetes as follows. Number 1, the Kubernetes API server is started with the client CA file argument. This provides certificate authority information to be used to validate client certificate presented to the API server. Users that want to authenticate against the API server need to request an X509 client certificate from the CA. This should be a secure and audited process. The subject's common name, the CN attribute in the subject of the certificate, is used as the username attribute when authentication is successful. And number 3, the user must present the client certificate during authentication to the API server, which validates the certificate against the CA. Based on that, the request goes through the authentication process successfully or is rejected. And that brings us to the end of this video. If you are interested in the summary of this video in GIF format, you can check that up from my LinkedIn handle. Thank you for watching and see you in the next video. Bye.